In this video, we're going to be looking at estimating the area under a speed time graph. Now, this area under speed time graph actually is equivalent to the distance traveled. And to estimate this, we're going to split up the graph into kind of shapes and then work out the area of these shapes. So if we look at an example, we've got this speed time graph for the speed of a car over a 30-second period. Work out how far the car travelled. So we got speed on our y-axis and time on our x-axis. So this shape here, we're going to split up into a triangle and a rectangle, and we're going to work out the area of these. So our triangle here goes from 0 to 8, so there's a distance of 8 there, and it goes from 0 to 20, so it has a height of 20 there. So the area of the triangle, well, we're going to do a half base times height. So we're going to do a half times by 8, that's my base, times my height, which is 20. So half of 8 is 4, 4 times 20 is 80. The rectangle, well, this is even easier, it's just base times height. So we're going to do area equals base times height. So it's going to give me, well, the height is 20, that's the easy bit. But we have to be careful here, because our base is not 30. We start at 8 and go up to 30, so that's going to be a distance of 22. So we're going to do 22 times 20, which is going to give me 440. So the area, or the distance travelled, is going to equal these two values added together, which is going to be 520. Now we're dealing with seconds and seconds, but here we got meters, so this is going to be 520 meters. It's going to be a little bit different when we're looking at a curved graph. Now this is where it's going to be very much an estimate, because the shapes we draw under our curve are not going to be perfectly aligned with this line here. So let's look at the question. Here is a speed time graph. Use 3 strips of equal width to estimate the area of under the graph for the first 3 seconds. So we are doing the area of the graph up until this point here. So this bit we're not interested in, so we're going to ignore that. So the way we're going to do this is we're going to split this up into 3 equal chunks. Well, we got a distance of 3 seconds, split into 3 chunks, so it's going to be 1 chunk per second. We're going to draw up at 1, and this first one's going to create like a triangle. Now the second one, we've got 2 parallel sides here. We've got that one, and we have this one. And when we join it up, it's going to create a trapezium, even if it's very, very badly drawn. And then the last one, we've got that joining up with this parallel side here, so it's going to be another trapezium. So for my working, I'm just going to label these 1, 2, and 3. So number 1, it's a triangle. The base length is going to be 1, my height is going to be 2, so the area of that is going to be a half, base which is 1, height which is 2, half of 2 is 1, 1 times 1 is 1. Part 2. So this is a trapezium. So the formula for my trapezium is a half multiplied by a plus b. So a and b are my 2 parallel sides times by my height. I'm just going to clean this up a bit so I can see where it hits the line. So I'm drawing up at 1 until I hit the line. There, isn't it? We said, so that's 2. I'm going to draw up at 2 until we hit the line, which which looks like it is 3.3. So my area is going to be a half of 2 plus 3.3 multiplied by my height. Now in this one, my trapezium's the other way around. So my height is this 1. So 1 perpendicular to my 2 parallel lines. So 2 plus 3.3 is going to be 5.3. Multiply that by 1, so it's 5.3 still. Half of 5.3 is 2.65. Now the final section, again, is a trapezium. So we're going to do half a plus b. So here we've got our first value is 3.3. Our second value, again, I'm just going to clean this up a bit. I'm drawing up at 3 until I hit the line. Drawing across, I think that is 3.9. And times it by the height. Again, this is my height here down the bottom, which is 1. So 3.3 plus 3.9 is 7.2. Half of 7.2 is 3.6. And then we're timesing it by 1. So these are my 3 areas. So the total area under the graph, total, is going to be those values added together, which is 7.25. Now, again, we're looking at time in seconds and meters per second. So we've got the meters there. So my distance is meters. So it's going to be 7.25 meters.